which this could actually be a zero-G plane. It is in zero-G, but there is atmosphere in the room here. There's air conditioning and there's air, so the ball could be thrown off course. But if it was totally void of any atmosphere, that ball would go straight forever in a zero-G environment. Okay, I want to show you 3 things that I found looking around at some spacewalk footage. And these are things that cannot happen in the weightlessness of space and in a vacuum. And I want to stress the vacuum portion of this because in a vacuum, an object in motion will tend to stay in motion, yet these things are zigzagging and things are moving that shouldn't be moving. Imagine going in a car at 60 miles per hour, and you can stick your hand out the window. Well, your hand wants to blow into the back seat, right? Because the wind is so fierce, the atmosphere is so thick. So imagine at 100 miles per hour, what would happen? Imagine then at 1,700 miles per hour, what would happen? Your hand would blow off. Now imagine at 17,500 miles per hour. This is what they say the ISS is moving right here. 17,500 miles per hour. Well, in order for them to step outside for a spacewalk, there has to be a complete void of atmosphere. If you stuck your hand out the window of the ISS, moving 17,500 miles per hour up in space where they say they are, then you could have a sleeved shirt on, a long sleeve shirt, and it wouldn't even ruffle. It wouldn't even blow the fabric at all. Okay, so keep that in mind as I show you these 3 anomalies, okay? So I'm going to show you some clips of debris moving and changing direction and them displacing things by moving close to them. By moving their foot close to something, it moves. And I'm going to show you this is impossible. This is from a spacewalk. And here's what is a piece of debris, or actually we know it's probably a bubble. Now, it just made a right turn. Do you see that? And I superimposed the swimming pool, the NBL, the Neutral Buoyancy Lab, where they practice. Okay, so you can see nothing can make a turn. There has to be zero atmosphere for them to step out of a vehicle moving 17,500 miles per hour. There can be absolutely no atmosphere at all. Not even ruffle a feather or hair on their head if they were exposed, anything exposed. So right there is busted. It cannot make a turn like that. So every object in motion that's not tethered has to travel in a straight line. Here's another bubble. This is from a long time ago. Many of you have seen this already.
Notice it sounds like it's underwater too.
Ice or debris. It can't curve. It can't make turns. Objects cannot zigzag in a weightless vacuum.
All right, so that's the gist of it, conspiracy cats. Answer that question. How can an object, obeying the laws of inertia, traveling along in one direction at 17,500 miles an hour, suddenly make a right turn, then make a U-turn, then hook a left, then go straight up, then come back?
Solar winds.
Yeah, it's like
solar winds.
You stole my idea.
Yeah, solar winds.
Sorry, man. Cosmic winds. You can say cosmic wind.